Hey everybody, Mr. Jones back here with you. We're going to be talking about transformations of lines, not the Transformers like the movie, but transformations, close. I realized I had my mask around my neck there. Good times. You can see that this is going to involve that function notation that we may not have seen yet, but we'll talk more about later in the year. Just all that you need to know right now is this is like the name of this line. Okay, it's a weird name, but f of x is kind of the name of this line. Okay, and so what it's asking us to do here is say, okay, the function of f of x is shown on the graph. Okay, so it's saying, hey, this is f of x, this is that graph, that's its name. And it says sketch the following transformations. Okay, and it gives us these three kind of weird expressions with that function notation in it. Okay, so what it wants me to do is kind of take this line and perform a transformation on it. Now, what does that mean? Well, you can see that these have all these numbers kind of added or subtracted on the end of f of x, and that's going to affect how this transformation is going to happen. Okay, so all we talk about here in Algebra 1 is vertical transformations. Okay, Algebra 2, you're going to see a whole bunch more, but Algebra 1, vertical, meaning this line is going to move up or down based on what the plus or minus says. Okay, and so what's going to be helpful before I sketch a transformation, like we've done before with lines, okay, what's going to be really helpful to me is if I highlight the points where this line goes through. Okay, so if I draw a point there and there, right, these are just the corners that this line's going through. It's really going to help me because that is kind of what I'm going to go off of to make these shifts, okay? So there's the rest of my points. And okay, so that first transformation says f of x plus 4, okay? Now f of x plus 4, again, that plus 4 is kind of telling me, okay, take this f of x and move it up 4. That's what that's saying, okay? So this plus 4 at the end of this is telling me, okay, take that f of x line, the original, and move it up 4, okay? That's what that's saying. And it's really easy to draw, right? Especially when you have these points drawn, right? Because basically what we do is we go to each point and we count up 1, 2, 3, 4, and we make a new point there, okay? Take this, move it up 1, 2, 3, 4, there, 1, 2, 3, 4. So I'm just counting up 4 from each point, okay? The line itself looks really similar to this, right? And we would call these parallel lines, what we talked about last time, right? Because they're never going to touch. But it's basically moving this line up that many spaces, okay? Each point moves up 4 spaces. Or specifically, it's like we're taking the y value of these points and adding 4 to them, right? So if the y value of this point is 2, if we add 4 to that, it's moving it up to the y value of 6. And that happens for every point, okay? So that's what a transformation is it's taking the line and moving it up a certain amount of spots on the graph, okay? Let me do a couple more just to make sure you got it, and then we'll look at some more questions. All right, so if I look at letter B here, f of x minus 2, okay, you can guess that minus 2 is not telling me up like plus did. Plus meant up. Minus is going to mean down that many spaces, okay? So same thing, I look at my original f of x line, and I'm going to shift that down that many spaces. So it's going to be down 2. So I take each point and now count down 2 from it. Okay, and again, same thing. It's like these y values, we're subtracting 2 from them. So if this y value is negative 2, subtracting 2 from that would take the y value to negative 4. Okay, so there's my new line right there. Good. Okay, so that's what a vertical shift looks moving down. That's that minus that does that. Okay. So then letter C, f of x plus 7, you can probably guess what that's going to look like. Again, that plus 7 is going to tell me, okay, I'm going to take that. Plus means it's moving up. 7 is how many spots it will move. Okay, so 7. Okay, and so I count up 7 from each one. Boom, boom. And you notice the slope, okay, specifically the slope remains the same, okay, of these lines, right? When it's a transformation like this, the slope remains the same, but the y-intercept is definitely different, okay? And kind of like the same thing what I was saying with the y values are changing, but the x values are not changing, right? It's not shifting side to side. It's just moving this straight up that many spots. okay? So that's what that line looks like. Okay, so I hope you get the basics of transformations. All right, so I've got another example up here, and again, this is kind of using that knowledge of transformations to apply to this type of problem, okay? So this one says, same thing, the graph of f of x is shown, but it says if you shift it down 5 units, what is its new equation? Okay, so a different question, right? Because it's not just asking you to sketch the transformation and be done, it's actually asking you, okay, if you perform a transformation, like it describes there, what is its new equation? And again, anytime it asks for an equation with lines, it's asking for the mx plus b equation, right? Which has its two key parts. It's m, its slope, and its b, its y-intercept, right? And so let's actually do the transformation first, okay? But we're going to need to look at the equation and then determine, okay, what is its slope and what is its y-intercept, okay? So if I shift this down 5 units, again, the key first is that I highlight some points on here, okay? So there's a point, there's a point. And again, I drew it and then erased the point, so you might be able to see still, but I'm doing it quickly. It might take you a little bit longer than it takes me, but there's where it goes through the corners, okay? There's where it goes through the corners. So I look at that and I think, okay, I'm going to take each of those points and I'm going to shift them down 5 units, okay? Or at least the ones that I can fit, right? Because sometimes this happens. It shifts down far enough where you can't actually fit them on your graph, okay? I count from each point and I just count down 5. 1, 2, 3, 4, 5. And I usually like to start with my y-intercept because, again, that's helpful. That's a solid point. 1, 2, 3, 4, 5. And again, the slopes should be the exact same as the original. Okay, so that's all I can fit. Okay, but there is the transformation line, right? Shifted down 5 units. And again, it doesn't say it like this, but again, how we would say this in function notation would be f of x minus 5, right? But anyway, it's not asking for that. It's asking for this pink line, this equation, okay? So I need to determine, okay, looking at this, how I drew this, what is its equation, okay? And so we've done problems like this before, right? Where we look at a line and we think, okay, what's its equation? And so, again, I need to determine these two things. I need to determine the y-intercept, where it crosses the y-axis, and the slope, how much is it moving from point to point. So this line, it goes through the y-axis all the way down here, right? That's where it touches this y-axis. And that is all the way down at -9, okay, -9. So I know this equation is going to be y equals something times x, and then that b value minus 9. Okay, that's what I know right now, okay? And then the m value, again, I count how much is it moving, and again, that's going to be a fraction. So it's going to be something over something. And so I count, right, from my left point furthest on the left, I count how much is it moving up till the next point, so that'd be up 2. And then how much is it moving right? 1, 2, 3. So up 2, right 3. Now let's check that a couple more times. Up 2, right 3. Yep. Up 2, right 3. Yeah, so that's a solid slope. That's how much it's moving from each point, okay? So that would be the equation of this line, okay? So that is the transformation and the equation of it, okay? Do one more question like that and then move on to something else. Okay, so similar question. It says the graph of f of x is shown. Again, that's the name of this line. It says, what is the equation of the transformation f of x minus 2? Okay, so similar question, okay, with a similar line drawn. And so what we want to do is determine the equation of the transformation once I actually shift it around, okay? And so I already drew the points for you here just to save some time, and I got my equation here, okay? But again, I want to look at this and think, okay, what is that shift? What's happening there, okay? And that minus 2 is, again, telling me take each point and move it down 2 spots, okay? Which is going to look like this. It's going to look pretty similar to the line I have, right? They're going to be pretty close to touching each other, but not quite. So there's the equation. And you can see that, wow, those aren't very far away at all. Yeah, and with a steeper slope like negative or whatever this slope is, we'll figure that out in a second. Yes, it's going to be closer. Okay, but anyway. So it's asking, okay, what's the equation of this transformation? Now, the common mistake here is to say, okay, -2, and they put that as the b value. So they'd say like y equals something x minus 2, okay? And that's a really easy mistake to make because that's kind of another way of describing what this line is, right? But again, you remember what the b value is, okay? The b value is where it touches the y-axis, okay? And that's not necessarily going to be the same as this, okay? So that -2 is actually not going to be involved in the equation at all. It's just that number tells you how many spots to shift it. But my equation is something totally different, okay? So that -2 is not involved, okay? I need to determine my same two things, my y-intercept and my slope, okay? So my y-intercept, again, where does it touch the y-axis? Well, the purple line touches right here. Okay, and that would be at +1, so that's +1 as a b value, okay? And then my m value, my slope, how much is it moving? Well, I start with the point furthest on the left, and I count to the next one, okay? So I move down 1, 2, 3, right 1, down 3, right 1, down 3, right 1. So down 3 and right 1 would be -3 over 1, or just, you could say y equals -3x plus 1, okay? So that would be the equation of this line, okay? Again, same thing, but again, I just wanted to cover it because it's a common mistake. That -2 is not included at all in the equation, okay? That's just telling you how many spots to shift, okay? Very good. Okay, so that's it for transformations. Good job, and we'll go over a couple more things in Unit 3, and then we are done. So good job. Thanks.